Hi friends. So today let us learn about chemical reactions and equations. So question and answer. What is chemical reaction? When two substances interact with each other and produce other substances leading to change in state or temperature or color, we say chemical reaction has happened. What happens when magnesium ribbon is heated using a burner? So this image is taken from the soft copy of NCERT textbook. The copyright is completely belonging to NCERT. We don't have any copyright on this. We are using it only for educational purposes. Magnesium ribbon burns with a dazzling white flame and changes into white powder, which is magnesium oxide. This is the chemical reaction between magnesium and oxygen in air. What happens when zinc granules are mixed with dilute sulfuric acid in flask? Again, this image is from NCERT textbook. All the images copyrighted by NCERT, only the copyright belongs to them. Here we are using them only for educational purposes, not for commercial purposes. So zinc chemically reacts with the sulfuric acid to give zinc sulfate and hydrogen gas. And the hydrogen gas, which is H2, that is two atoms of hydrogen in one molecule of hydrogen, escapes from the gas tube. Of course, in the gas there will be many molecules, but H2 means two atoms of hydrogen combined to make one molecule of hydrogen. Okay. Give example of word equation for chemical reaction. So how do you specify an equation, chemical reaction, using a word equation? Okay. So if we want to say magnesium and oxygen react with each other, we can write magnesium plus oxygen, and we can bracket we can write them as reactants because they are the ones who are reacting with each other. And we can say it gives, the arrow mark says these two react to give magnesium oxide, and under this magnesium oxide we can say product. Okay, so product, because this is what is got out of the chemical reaction. Give example of chemical equation for chemical reaction. Instead of word equation, more scientifically it is better to use the chemical equation, because magnesium, the chemical formula is Mg. Okay, the element formula for magnesium is Mg, and oxygen in the air is in form of oxygen molecules, and each oxygen molecule contains two oxygen atoms. So you have O subscript 2. Okay, both of these guys react to give you MgO, that is magnesium oxide. Okay, so this is the chemical equation for the reaction. What can neither be created nor be destroyed in a chemical reaction? See, the mass can neither be created nor be destroyed in a chemical reaction. So, the number of atoms of each element on the left hand side must be equal to the number of atoms of each element on the right hand side of the chemical equation, because the atoms just break bonds between one another and form new bonds with each other, bringing out new substances. But the atoms by themselves are neither created nor destroyed. What is an imbalanced chemical equation? An incorrect equation where the number of atoms on the left hand side are not equal to the number of atoms of each element on the right hand side is called a imbalanced chemical equation. For example, if you look at the question number 5, we have one atom of Mg and two atoms of oxygen, correct? But on the right hand side, you can see there is only one atom of oxygen. So where did the other atom go? Which means this is a imbalanced equation and it's wrong. We have to balance it out. What is a balanced chemical equation? Correct equation where the number of atoms of each element on the left hand side are equal to the number of atoms on the right hand side is a balanced chemical equation. For example, if you take zinc Zn plus sulfuric acid H2SO4, right, that will give you ZnSO4 plus H2. So you can see the zinc element has one atom on the left hand side, one atom on the right hand side. Sulfur has S, one on the left, one on the right. Oxygen has four atoms on the left, four atoms on the right. H2, hydrogen, has two atoms on the left, two atoms on the right. So this is a balanced equation. Okay, so we are showing it in this table. Okay, zinc has one atom on LHS and RHS. Hydrogen has two atoms, LHS and RHS. Sulfur has one atom, LHS and RHS, and oxygen has four atoms, LHS and RHS. Okay. Now, let us say we are given an equation which is imbalanced. imbalanced. For example, this equation Fe, which is iron, okay, the chemical formula is Fe, which is derived from ferrous, okay, plus H2O, which is water, will give you iron oxide Fe3O4 or ferric oxide, however you want to call it. So Fe3O4 is either iron oxide or ferric oxide plus H2, okay, which is hydrogen gas. Now this is definitely imbalanced because you can see we have Fe3 atoms on the right hand side and only one on the left, and O atom we have four on the right and only one on the left. So this is an imbalanced equation. So how do we balance it? See, the technique for balancing says that first you should draw boxes around each of these compounds, okay, because the number of molecules can change but the number of atoms inside a molecule will not change while balancing equation. Fe3O4 will remain as Fe3O4 only. It will not become FeO3 or Fe3O5. It will never become like that, okay. So the molecule will remain as is. Only the number of molecules participating in the equation can change. Okay, so step one is draw boxes around these compounds in your mind. Okay, this we have shown it on the screen, but in your mind, draw the boxes and don't change anything inside the boxes. Just that there will be multipliers which will be written to the left of each of the compounds. Okay, and start with a compound which has maximum number of atoms. For example, in the right hand side, look at Fe3O4 iron oxide. It has 3 iron atoms and 4 oxygen atoms. So we can choose that molecule to balance first. Okay. To balance, see, Fe3 on the right has 3 atoms. So why can't we put 3 next to Fe on the left, right? So if we put 3 Fe on the left, then we'll have 3 atoms of Fe on the left also and 3 atoms on the Fe on the right also. This is good, but you know, if the iron atoms are balanced, we have to balance the rest. Okay, so let's take O next, oxygen. There are 4 on the right hand side. Okay, so we have to put a 4 next to H2O to give to balance that. Okay, so now left hand side also has 4 oxygen atoms, right hand side also has 4 oxygen atoms. But see what has happened. Look at H, look at the hydrogen atom. There are 8 on the left, but there are only 2 on the right. So you have to add another multiplier. So finally, we write it as 4H2. So 3Fe plus 4H2O is equal to gives Fe3O4 plus 4H2O. So this is how we balance the equation. We'll balance more chemical equations as we go ahead, but this is the example of how to do it. How to indicate the physical state of a compound in a chemical reaction? See, you can denote the physical state by bracket S. Bracket S means solid, bracket G means gas, bracket L means liquid, and any compound which is present as a solution in water can be represented by bracket AQ, which is aqueous. Okay. Now, in the above equation, you can see that 3Fe, which is the iron, it is solid, isn't it? So we have put as bracket S and 4H2O. Okay. Now, the water is in form of steam here. Okay. That's why we have put it as G, which is gas. Okay. Which gives iron oxide, Fe3O4, which is also solid. That's why we have put it as bracket S. Okay. Plus 4 molecules of hydrogen, each having 2 atoms, which is also gas, right? That's why we have put it as G. Okay. How to indicate conditions in which chemical reaction takes place? See, you can write it on top of the arrow at which condition, at what conditions the reaction will take place. For example, if you take CO, which is carbon monoxide, which is a gas, and H2, 2 molecules of H2 hydrogen, 2 hydrogen molecules, and you apply pressure on it, that is compress them. Okay, you compress them to 340 atmospheres. See, when you go outside, the normal pressure is around 1 atmosphere, etc. Now when you pressurize carbon monoxide and hydrogen to high pressure of 340 atmospheres, you will get a compound CH3OH, which is methanol. Okay. Similarly, another example is if you give carbon dioxide, okay, and you have water, right? The chlorophyll inside plants will convert this to glucose, oxygen, and water. Okay, so this reaction, which is photosynthesis, will happen under sunlight inside the trees because they have chlorophyll. So the trees will absorb all the carbon dioxide from our atmosphere, and they will take water from the earth, and they will convert it into glucose substance, which is C6H12O6, six carbon atoms, 12 hydrogen atoms, and six oxygen atoms all put together. C6H12O6 is the glucose. They will convert this in photosynthesis to glucose, which will be consumed by humans. And in process, they will give out oxygen also. So trees are good that way. They absorb carbon dioxide and give out oxygen. Okay. Write balanced equation for below reactions. Hydrogen plus chlorine is equal to hydrogen chloride. Okay. Now, two atoms, one molecule of chlorine, that is two atoms of chlorine will react with two atoms of hydrogen to give you two molecules of hydrogen chloride. So Cl2 plus H2 is equal to 2HCl. Okay. In hydrogen chloride, there's one atom of hydrogen and one atom of chlorine. Barium chloride plus aluminium sulfate is equal to barium sulfate plus aluminium chloride. Okay. Now, aluminium sulfate has two aluminium atoms. Okay. And SO4 combination, it has three of them. Okay. What is the SO4 combination? SO4 is one sulfur and four oxygen atoms. Okay. So that combination, it has three sets of them. Okay. So the aluminium sulfate has two aluminium atoms, three sulfur atoms, and 12 oxygen atoms. Okay. So that is aluminium sulfate. Okay. This will react with three barium chloride atoms. Okay. What is barium chloride? BaCl2. Ba is barium, Cl is chlorine, and there are two atoms of chlorine. So BaCl2 is barium chloride. To give you, when these guys react with each other, they will give you aluminum chloride. What is aluminum chloride? AlCl3. Al is for aluminum and Cl is for chlorine. Okay. So AlCl3, there are three atoms of chlorine, and barium sulfate, which is BaSO4. Okay. So this is the reaction. Sodium plus water giving you sodium hydroxide plus hydrogen. Okay. Now sodium is represented by Na. Okay. So two molecules of Na plus two molecules of water, okay, which is 2 times H2O, gives you two of sodium hydroxide. Sodium hydroxide, the chemical formula is NaOH. It has one atom of sodium, one atom of oxygen, and one atom of hydrogen. Okay, NaOH is sodium hydroxide. Okay, so when you let the sodium interact with water, it will give you sodium hydroxide, and the other component you will get is the hydrogen. Right? Balanced equations with state symbols for below reactions. Okay, so we will describe a situation in words. We need to write balanced equations for these. So we have solutions of barium chloride and sodium sulfate in water, and it will react together to give an insoluble barium sulfate solution and sodium chloride, barium sulfate solid, insoluble barium sulfate solid, and solution of sodium chloride. Okay, so when you want to write this chemical equation, you can see barium chloride is BaCl2, okay, and sodium sulfate Na2SO4, sodium sulfate, two atoms of sodium and one combination of SO4. So BaCl2 plus sodium sulfate will react to give you BaSO4 plus 2 times sodium chloride. What is sodium chloride? It is NaCl. Na is excuse me. Na is sodium, Cl is chlorine. Okay. So this is the equation. Now BaCl2 and sodium sulfate both are aqueous because they are both solutions. Okay. Barium sulfate is an insoluble solid, so we have put it as S, which is solid. Okay. And sodium chloride again is present as a solution in water. So we have written it as bracket AQ, which is aqueous. Okay. Now next sentence: sodium hydroxide, that is NaOH, reacts with hydrochloric acid, which is water, which is HCl, right? Which is a solution in water, to produce sodium chloride and water. Okay. So NaOH, which is aqueous, AQ, reacts with HCl, hydrochloric acid, which is also AQ, to give you NaCl, sodium chloride, which is a solution in water. So it is AQ plus H2O. H2O is water, it is liquid. So we have put it as L for liquid. During chemical reaction, do atoms of one element change? No. In a chemical reaction, atoms of one element do not change into those of another element. Neither are they created nor they are destroyed. The process of breaking the old bonds and making new bonds to produce new substances takes place. Okay, so atoms by themselves will not change. They'll just break the old bonds and form new bonds. For example, in the equation above, you can see that sodium, oxygen, and hydrogen atoms are together in sodium hydroxide. Okay, and hydrogen and chlorine are together in hydrochloric acid. When they two react, they break their bonds. Okay, the sodium breaks its bonds from oxygen and hydrogen, and it will go and make new bond with chlorine to give you a sodium chloride. And the hydrogens and oxygens will come together and make a bond to give you water, H2O. Okay, so the atoms are not appearing or disappearing or getting created or whatever. That's not happening. It is just that the atoms are breaking the old bonds and creating a new bonds which are stronger than the old bonds. That's why chemical reaction is there. What is a combination reaction? A chemical reaction where a single product is formed from two or more reactants is known as combination reaction. Give an example of combination reaction. See, when two substances are combined together, for example, CaO, Ca is calcium, okay, O is oxygen, CaO is calcium oxide, okay. When it is combined with water H2O, it will give you calcium hydroxide, CaOH2, okay, and the byproduct will be heat emission. Okay, so the calcium oxide plus water is giving you calcium hydroxide, and two products, one is calcium oxide, one is water, together are combining and giving you another product. This is an example of combining stuff, that is combination reaction. Calcium oxide reacts with water to produce calcium hydroxide, called slaked lime, and also releases large amount of heat. Okay, give applications of calcium hydroxide. See, calcium hydroxide, when you just leave it to air, it reacts with the carbon dioxide in the atmosphere to give you calcium carbonate, okay, plus water. So calcium hydroxide reacts slowly with carbon dioxide in air to form thin layer of calcium carbonate on the walls. So if you just whitewash your walls with calcium hydroxide, slowly it will form a thin layer of calcium carbonate, thereby making the walls smooth and strong. Okay, this is why calcium hydroxide is used for whitewashing. Okay, give few more examples of combination reactions. See, carbon, okay, Ca is calcium, C is carbon. Both are two different elements. O2, oxygen, right? The carbon combines with oxygen, and when you make them react, it will give out carbon dioxide, CO2, plus a lot of heat. Okay, carbon in form of coal reacts with oxygen in air to give out carbon dioxide when they are burned together, and a lot of heat. And this heat is used for steam engines, etc. Okay, 2H2 plus O2 is equal to 2H2O. Okay, two molecules of hydrogen and one molecule of oxygen react together to give you two molecules of water. This is also combination. Hydrogen and oxygen is combining together to give you water. Okay, what are exothermic chemical reactions? Chemical reactions in which the heat or energy is released along with the formation of products is called exothermic. That's why it's called exo. Exo means it is getting released. Exothermic chemical reaction. Give few examples of exothermic reactions. Okay, CH4, okay, is a compound called methane, which is there in natural gas. When you burn this, it will react with oxygen in air to give you carbon dioxide and steam and lot of heat. Okay, when you burn natural gas, which has methane, CH4, methane is carbon atom with four atoms of hydrogen. CH4 is methane that, when burnt, reacts with oxygen to give you a carbon dioxide and lot of heat, which is why it's exothermic. Similarly, inside our cells, the glucose C6H12O6, okay, reacts with oxygen that we breathe to give out carbon dioxide, water, and energy. Okay, so the rice, potatoes, bread, whatever we eat contain carbohydrates, which are broken down into glucose. Okay, and this glucose inside our cells combines with oxygen in our body and provides us with energy, and the byproduct is carbon dioxide, which we breathe out. We breathe in oxygen, we breathe out carbon dioxide. Okay, and it is reverse for trees. They breathe in carbon dioxide and they give out oxygen. What is decomposition reaction? See, composition is adding together, decomposition is breaking it apart. Okay, they both are opposites. Combination reaction is combining two compounds together to get a product. Decomposition is taking a single compound and breaking it to get simpler products. Okay, a reaction where a single reactant breaks down to give simpler products is known as decomposition reaction. Give examples of decomposition reaction. If you take ferrous sulfate, okay, FeSO4. Whenever SO4 comes, remember that it's a sulfate. If you take ferrous sulfate and you heat it, okay, it will break down into three components. One is ferric oxide, that is Fe2O3. Ferric, Fe2, Fe is iron, remember that. Ferric oxide, Fe2O3, plus sulfur dioxide, which is SO2, and sulfur trioxide, which is SO3. This happens when it is heated. That's why it's a decomposition. It is breaking from FeSO4 into three components. Similarly, if you take limestone, which is calcium carbonate, CaCO3, and heat it, you will get calcium oxide and carbon dioxide. Okay. So here also breaking up is happening, decomposition is happening. Decomposition of calcium carbonate into calcium oxide and carbon dioxide. Okay. Similarly, if you take lead, Pb is lead, NO3 is nitrate. Okay. Just like SO4 is sulfate, NO3 is nitrate. So lead nitrate, which is PbNO3 bracket 2. Okay, when you heat it, it breaks into lead oxide, which is PbO. Pb is the symbol for lead. Okay, lead is a kind of an element. Okay, and Pb is the notation for that. So when you take lead nitrate and heat it, it breaks into lead oxide and nitrogen dioxide. N is nitrogen, O2 is two oxygen atoms. So NO2 is nitrogen dioxide. Just like CO2 is carbon dioxide, NO2 is nitrogen dioxide. Okay. And another example, when you take silver chloride, Ag is the symbol for silver, Cl is the symbol for chlorine. AgCl is silver chloride. Okay. When you expose it to sunlight, it breaks into silver Ag and chlorine Cl2. So decomposition of silver chloride into silver and chlorine by sunlight. Okay. Similarly, when you take water and pass electricity through it, it decomposes into hydrogen and oxygen. Okay. Decomposition of water into hydrogen and oxygen using electricity is also an example of decomposition reaction. Again, this image is taken from NCERT soft copy of the textbook, but the copyright is theirs, and we are using it only for educational purposes and not for any commercial purposes. So we have a beaker in which you have water and you have two anode and cathode which are connected to the battery. Okay, and we add a little bit of sulfuric acid in the water to make it, connecting, so that it can make the electricity flow inside the water a little easier. Okay, and then you take two test tubes, and on the two anode and cathode you just invert it with water, and you collect the gas at the top. Okay, and you see that oxygen and hydrogen are created. They are decomposed from water, giving oxygen and hydrogen. Okay,